Oh shit. It's tutorial time! Hello, so today we will be doing the debugger and the testers. We will be learning how to test and how to debug, how to make sure our code is good. We will be covering briefly how to deal with compile time errors, because that's something that we should probably all be familiar with and it's pretty easy to do. And then we'll be covering in detail how to deal with exceptions that you see during your code, how to use the debugger, and how to write your own testers to fix logic errors. So while we get started, there's a Google Doc as usual, which I will link in the Zoom chat. Please let me know if there are any issues with receiving it. That will contain a lot of information, and I will have a nice little slideshow to show off to you guys as well. So let's get to that. Alright, so here we've got some goals. Compile time errors, eliminate them. Exceptions and crashes, eliminate them. Logic errors, eliminate them. Hella good testers, make them. Alright, here are the quick tips, a quick rundown. And if you guys have any questions, it's time to ask now basically, right? So, compile time errors. You see a red underline in your IDE and your code will not compile. That is an indication of a compile time error, and you don't like them. You don't want them to happen. They are not ideal, but they're pretty easy to deal with. You can hover over them to see the details, and then you can usually, in IntelliJ, you can usually right-click and have it be automatically fixed. They're mostly caused by typos and other similar errors, and usually also your syntax might be wrong. And then runtime errors are caused by exceptions being thrown somewhere. So, for example, if you get a null pointer exception or a class cast exception, those are runtime exceptions, and that's because something somewhere went wrong. It stems from a line of code, and it's usually caused by the lines before that line, and you can fix it using the debugger. Do you guys have any questions regarding compile time versus runtime errors? Alright, and if you do and you weren't, you're like watching the recording or you don't have a chance to ask, is the red line the same in Eclipse? It should be. There'll be like a little red jagged underline in Eclipse, but you might not get the automatic fix for it. And yeah, I know the zoom might be low frame rate. That's because I'm prioritizing resolution over frame rate so you guys can actually read it. If I made it all silky smooth 60 FPS, it would be very pixelated and you couldn't read the code, so trade-offs there. Alright, so here are the important terms that we're going to be seeing today. There's going to be the stack trace, which is just this printout of what is actually going on when there's an exception. The stack trace is those red lines that come up when you have an exception in your code. That we refer to as the stack trace. The debugger is a tool that we use to make our code run line by line. If you're from ECSE 202, or not ECSE, if you're from Comp 202, you will have seen the Thani debugger where you can run line by line. It's basically that. You can run your code and see all the values of the variables as it runs. A breakpoint is a specific line which tells the debugger to pause at that specific point, and that will help you view the values of all the variables at that time. So if you have a breakpoint, let's say on line 30, your code will pause on line 30, it'll stop running, and it'll show you all the values of the variables. Now once you've paused, you can use step over to go to the next line, and then pause on the next line. It's kind of just like an advance to next line button. And step into is a button which then goes into the method that you're calling on that line. So if you call, let's say, method A on a given line, and you call step into, you'll enter method A by pressing step into, and you'll basically run that line by line. A tester is, of course, a program which tests your code. It tests that a different program is working properly. Try-catch block is something we'll probably be seeing a fair bit of. That is something that helps us deal with exceptions. So if an exception is thrown in the try block, it will be sent to the catch block. And then there's obviously a lot of detail on this in the written document if you guys need it. Are there any questions regarding any of these important terms? Alright, and I will be showing you guys how these terms look and like how all of this looks in your IDE. shortly. Let me just get this. Alrighty. Oh, I did not mean to do the fancy transition there again, but I did. Enjoy. I may as well use it. Alright, so here we've got an IDE, and we've got this bad ArrayList class. And I've written this, this is just continuing from the project from the last time, from the A1 review session. So if you were there, you probably remember this animal, cat, dog stuff. Well, I'm just using that same project here, and I'm going to write a tester for cat, dog, and animal. But first, I'm going to show you guys compile time errors. So here's a compile time error. You can see it's red. The text turned red here. It wasn't necessarily an underline, but the actual name of the thing turned red because it says cannot resolve symbol. That just means this variable can't be resolved. You can just make sure that the variable you're using is actually valid. In office hours and stuff like that, I might see something a lot like this. Like say you put like the circle brackets after array, but it's not a method. So again, here it will it'll tell you unexpected token. It'll underline it red, and lots of things will turn red. Basically means your code can no longer compile. It's not working. These are compile time errors. They're really common, but you would be surprised how often it is that students come by and ask about like compile time errors where it's pretty clear that all these text is red underlined, and it's like, where is my mistake? Well, if you are ever in this situation and you're feeling like your code is completely broken and everything is wrong, the way you fix it is you go from top to bottom. So I'm just going to mess up this code really quick. I'm going to add a bunch of invalid stuff here. You know, just completely mess up this code, right? Now it looks like basically everything is red here, right? Well, the way we fix this is we have to go top to bottom, because if you screw up something at the top, you notice that the things below it also turn red, and the things below it also get screwed up. Well, for that reason, we want to do our fixing top to bottom. I'm going to fix these mistakes as they come up. First one I see is missing method body well, yeah, it thinks it's a method because I put these brackets here, but I want it to be a field, so I just get rid of those brackets, and now that fixed some of those errors, right? So fewer things are red. And now this one, I add the correct spelling. You can see I missed a T there. So now this should also be fixed. And then also I don't have my method parameters, but my IDE will even fix that for me. See, as I go down, less and less errors exist. See, more errors get fixed over here by me fixing stuff up there, and they go top to bottom. So yeah, when you're fixing, you want to go top to bottom. Here it's animal, don't want the typo, and here it's void, right? And now all of my compile time errors are fixed, and that's kind of the procedure. You just go top to bottom and you make sure everything is in valid Java syntax. Very common is brackets are wrong. You know, you have circle brackets where they shouldn't be. You have some triangle brackets for some reason. You know, these kind of issues are very common. If anybody has any questions regarding fixing compile time errors, now is a good time to ask. I know I went over it a little bit quickly, so I'm welcoming anyone who has any questions regarding those. Alright, one more note on compile time issues is that in IntelliJ, not so much in Eclipse, but a lot in IntelliJ, you'll get these yellow highlights. These yellow highlights are not compile time errors. These yellow highlights are more so, they're indications that your code might not be optimal. So it's actually like this intelligent system that says things like, you know, the cast may be removed, so you might not need to cast something. If you can change the variable to dog. It's stuff like that. So it's suggesting you to change your code in ways that will behave the same way, but will be different. So yeah, these yellow highlights are designed to, well, help you improve your code, but your code will run just fine without them. And when you accept yellow highlight suggestions, it behaves the same. Alrighty. If the file automatically compiles, can we assume there's no compile time errors? Yeah, you can assume there's no compile time errors if it can run. Could I go over the grading scheme, automatic 40%, etc.? Sure, well, the grading actually works like this. We have a tester, like a debugger, similar to mini tester, and we grade you based on how many tests you pass. The mini tester we supply is a portion of that tester. You can expect somewhere around 40% of your grade to be accounted for by the part we release, so that's mini tester. Then beyond that, we have additional tests that are not in Minitester, which we run, and then we just tally up how many of those tests you pass, and you get your grade. Then if you want to kind of cheat the system a little bit, you team up with your friends or with other people in the class, you make a cool tester, that is perhaps more similar to what we're grading you on. So this is why this session is kind of useful. If you learn how to make a good tester, you could extend up mini tester, make it really elaborate, and then you could guarantee yourself a little bit of a higher grade. That's the way the grading kind of works on it. And yeah, if the file automatically compares, there's no compile time errors. And that's basically all I really have to say for compile time errors. Now we can get more into something like runtime errors. Well, how do we run into a runtime error? How do we find a situation where there's a runtime error? Well, first thing we want to do is we probably want to create a tester. So when I make a tester, I usually just make a new.java file. I'm going to call it, let's say, a tester. I'm going to call it, it's a tester. And in tester, I'm going to want to try different things. So in my tester, why don't I try to use my bad array list? Now my bad array list is going to have to be able to get items, to add items, and to remove items. I'm just going to write a quick add method. I'm not going to think too much about it. I mean, hey, it's just adding, right? Public void add, we got to add an animal A. And now we can just say, well, why don't we just say items at items.length plus 1 equals A, right? So there's no compile time error. There appears to be no issue. I'm just saying that the next item in the array is going to be A. I know this is wrong, but I'm going to find that out using my tester. So I'm going to say public static void test ArrayList, and I'm going to say bad ArrayList A is equal to new bad ArrayList, and I'm going to say a dot add, let's say new dog. I'm going to just add a new dog to the package of age 4, or a new dog to the array list, and then I'm going to try to say system.out.println a.get 0. Let's see if this works. Let's put this in a main method, main string args, right? And I'm just going to call my test method. This is a very simple tester. You can make them very elaborate, and at the end of the session I can show you how to make them very fancy. But for now, I can show you guys the very basic version. So this is a very simplistic tester that tests the bad array list class. If I run this, what'll happen? Well, I get this array index out of bounds exception. So can anybody tell me, what should I do with this exception? And is there some useful information that I'm getting from this stack trace? So yeah, line 13 in the file. And how do you know it's line 13? How do you know it's not line 9 or line 4? Start from the top. Yeah, that's right. So when you read your stack trace, the most specific line is at the top. The most specific line is at the top because that's like the one that was called most recently. And somebody was asking about the GitHub test. I'll send that over to your Zoom chat there if you guys want it. It's a student tester. So yeah, this will show you the most relevant thing at the top. But now how do we deal with this exception? Do we just read line 13? Or is there some way we can deal with this which can actually let us go through it? Well, that's what the debugger is for. So in your most simple case, using the debugger, you just put a breakpoint on the line you're testing. And then you're able to pause the program when it hits here. To do this, you just press the bug icon when you're running. So when you're debugging, there's two things you need. You need a breakpoint on your line, and you need to press the bug icon. If I don't have a breakpoint, and I press the bug icon, nothing happens. It just runs the program normally. And if I have a breakpoint, but I don't press the bug icon also, nothing happens. The program runs normally. To use the debugger, you use the bug icon, and then it'll actually enter this method, and it'll pause. Now I have access to my controls. I can step over and step into. These are the important ones. Force step into and step out of are not super important. Step out lets you go out of what you're calling into the method that called this, which here would be some weird Java crap. And force step into will step into things, well, basically no matter what, even if you shouldn't. But we really only care about step over and step into. So here, if I step over, it's going to go to the next line. So what I'm going to do is I'm going to click step into, and that's actually going to enter the method I'm calling. You can see when I stepped into here, it entered this method. And now, as I go through, I can see the values of my variables, and I can see what's in my memory. So this region of the screen right here, where my face is to where the mouse is, this is the memory. This is what's currently in your memory for this program. Then Up here obviously is your code, and next to the variables you can actually see what they are. So if I hover over bat ArrayList A, I can actually see its details like that by hovering over it. And if I hover over the add method, let's say, or not the add method, if I hover over like new dog, for, or any of these various items, I can get their information. So here I guess A is the only real thing that exists. I can even set its value so I can mess with it in the debugger. And I can do all this crazy stuff. But what we really care about is the fact that we can see A in our memory and we can see items as an array of length 0. Now we know that we crash when it adds. How do we know this? Because if we look back to our original stack trace, it said that line 4 is where we had our crash come from. So when we reach line 4, which we did, we can step into once again. And now we have this purple. So we either step into the constructor of dog or we step into the add method. So here we know that the add method is what screwed us over because of the stack trace. So when we step into, we can either click on dog or add, but I'm going to click on add. And now we're inside of the add method. And here we can see our exception. And in fact, you see our program didn't crash yet, but our IDE already tells us where the exception is coming from. It's saying accessing items length +1 will cause an array of index out of bounds exception. And we can already see that that's going to happen before it even happens. So we know exactly why it's happening. We know that animal of length 0 at 811 trying to access index, what's the index here? The index is 1. If I hover over the plus, it'll give me the value. So the value is 1. And it says that this is invalid, you can't access this index. And now I've identified where my exception is coming from. And my tester helped me do this. If I didn't have my tester, I would never know that this would have caused the exception, right? And I can still see all the values of all my other stuff, but that's not important. What's important is that that's why the exception is happening. So do you see how the debugger kind of helped us understand why our exception is happening?
Question.
Yeah.
Can you go back to the tester?
Sure.
So you said we know that it's the add method that's causing the problem, right?
Yeah.
How do you know that and not the dog?
Because when the first time we ran the program, see we have this this stack trace here, and as one of the people here pointed out, line 13 is where our exception is coming from. But line 4 is also where our exception is coming from, because our exception is coming from the fact that here in line 9 we call this method. Then we wait for it to do whatever it does. We know that whatever it does causes an exception. Why does it cause an exception? Because whatever line 4 does causes an exception. That's why we know this. And then why does line 4 cause an exception? Because whatever line 13 does is causing an exception. So it kind of jumps up the stack trace, right? So we know that line 4 is definitely going to have something to do with the issue. Like whatever is happening in line 4 is causing the exception. We know this because of this. Does that kind of make sense?
Yeah. All right. Thanks.
For sure. And if you don't know why the exception is happening, you could just run through the entire thing and see what happens. Emma's asking, does it work similarly in Eclipse? The answer is yes and no. So it's similar, but it's not the same. The user interface in Eclipse is a little bit different, and it doesn't give you the option to like hover over things necessarily as easily and like see their values like that. And it doesn't as easily let you do, what is it that it doesn't let you do? Like compare the evaluations and stuff. It doesn't let you do that stuff, but it does let you do this in some level. It's going to look different, and I would say it's quite a bit more difficult in Eclipse. So if you're trying to do this in Eclipse, you're probably going to struggle a fair bit more than in IntelliJ, where it's made very, very simple. That's why I'm also teaching it in IntelliJ. So yeah, that's the general idea of the tester and the step controls and the debugger. Now I can write, well, first let me fix up my add method. I know that I shouldn't be accessing it like this. So, well, to add to an array list, we all know that it should be, well, you know, temp. I'll stop the thing too. I'll say animal temp is equal to new animal, what is it, items dot length +1. And now we can say temp at 0 is equal to a, and then for int I equals 0, I is less than items dot length I plus temp at I +1 is equal to let's say items at I +1, and then we'll say items equals temp. And now this should copy everything over. How do I make sure that it works? Well, I can do the tester again. Let's run the tester. Let's see if it still crashes. Okay, it doesn't crash now. And now my tester it prints out the value of the dog. And I'm trusting that it's legit, but let's just make sure. We can use the debugger even when there's no crash. And now I'll show you how to kind of just watch a program run. Even if it works, it can sometimes be great to just watch it run, which is what we'll do now. We know that the constructor of the bad array list, let's see how it works. So the constructor of the bad array list takes this items, which is null. It sets it to be this new array. Then it goes in here. We can add a new dog, the dog constructor. What does it do? It calls the animal constructor, sets the age, which is what super does, and then it sets the friends array to be a new array of animals. Cool. So we can just kind of watch our code run. And then here, if I do the more interesting one, let's say I want to do a.add, I'll just rerun it with the debugger. We can never step backwards. That's one thing about the debugger. You can only ever move forwards in time. So if you mess up there like I did, you got to rerun it, but it's not usually a big deal. Now we can step into the add method. Let's see, I want to see add. Now it looks a bit different. We can go through our loop, and we can see that as variables are created, they appear in our memory. So here we've got temp, and here we've got this. And we've also got, we got temp and we got items. Now this is actually a great way for us to see shallow and deep copy. So when you want to do a shallow copy, you want to make sure this memory address stays the same. So you see this at 827. You see how every object has an at afterwards? That number after the at is the memory address. If you're doing a shallow or deep copy, those are what you're watching out for. And it's very important that you keep paying close attention to them when you're dealing with shallow deep copy. So here we know that the items array has nothing in it, but once we step one forward, items has dog at 825, and temp has dog at 825. So we know it was a shallow copy. That's pretty important for A1, and it's just important in general. That's memory addresses in the debugger. And there's also this frames side. Does anybody want to guess what frames does? Like, what is this whole little box of the debugger for? All right, I'll give you a hint. It has to do with the stack trace. If we remember what our stack trace looked like, well, now it's clean. But when we had our bug, remember we had all these lines, which caused the issue. This is actually everything that's going on right now. So at the top highest level, so the bottom is the highest level, we're currently inside of the test array list method, right? So our blue line, our current line, is the test array list method. Then we're currently inside of that. Like if you ever watched Inception, this is kind of like Inception, how there's like different levels to the dream. This is like the different levels to how our code is running. From our main method, we're currently also inside of the test array list method. And then inside of the test array list method, we're inside of this add method. So you can see how we can step through the different levels of our code, sort of. We can see that all of the things we call will be added to this little stack. And we can actually move forward and backwards in these. So if I move forwards up here, it's actually going to cut it out like that. And that's another way we can step into and step out of. That's IntelliJ lets us do. That's very nice. So if we're done with whatever method, like if I was done with add, I could use that little block of the debugger to step out of add just visually. I can step into here, and notice when I step into another like level here is created, and I step into here again. And let's say, okay, I'm going through this, blah, 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 and I get bored. Let's say I'm stuck in this for loop. I don't care anymore. I can just click over here on one of the higher levels, and then I can just step over. Or I should just be able to step over. And then it's gone. And now I'm back in the main method, right? So that's another one of these tricks that we can use. We can step up and get out of there immediately. So that's what this one is doing. It's just showing us like our reference frames. If you were to do a multi-threaded program, which you will not see in Comp 250, you could also see all your different threads here. But that's a whole other thing that you don't need to care about. But if in your future courses, if you choose to continue doing these kind of CSE courses, you will most certainly see this debugger useful for multi-threaded debugging. All right, so are there any more or any questions otherwise about the whole debugger interface, how the UI works for the debugger, anything related to that? Can you go back to add for 1 second? Sure. And another trick is if you're in IntelliJ, you can hold control and then you click on a method and you can go right to its declaration.
Yeah, I just had a question. Temp I plus 1 equals items. Shouldn't it be just I since we're copying what's in the in the 0th spot to the first spot of the other one? Or am I missing something crucial?
No, you're totally right, and that would actually cause an exception later on. Like if we made a good, like a better tester, it will find that this will cause an exception sometimes. But yeah, since items is actually empty and items.length is 0, it never does this. But yeah, that would actually be more correct. And your ability to be a human debugger has trumped the ability of our tester to be a tester. So that's pretty good. Do we need to put the breakpoint in the main method? You can put the breakpoint wherever you want. So if I want to, I can put the breakpoint right into here, right into bad ArrayList. But what that'll do is that'll not freeze me inside of my main method. Now, if I rerun this with the debugger, notice my method did freeze, but it did not freeze inside of the tester class. See, this one never had it pausing here. It just freezed right where it was. So you can put the breakpoint in any possible lines you want, but it will only freeze where you put it. Alright, then you can obviously skip through, go through, and watch it run. Yeah, in Eclipse you can do similar things. You double click on the line to put a breakpoint and you press the debug icon to run it. It'll automatically ask you to switch to the debugging perspective. But again, I don't recommend trying to debug in Eclipse. The UI is a complete mess and it gets a little bit hectic to just try to work with it. The UI for debugging in IntelliJ is much easier to understand and much easier to use. You can get good at the Eclipse one, but it would take a bit of practice and a bit of learning compared to this. Alright, so now we can get back to our tester and we can do some more robust tests. So this very simple test is just testing that it gets added. But how do we know that the add actually worked properly? Well, we know the add works properly if we actually compare what's inside of the array. And this is usually a good strategy. So we want to say that instead of creating our new dog in here, we want to say, for instance, dog d is equal to that. And then we can say a.add_d. And then we can say, what is it? If a.get 0 is not, or I guess does not equals d, we will print an error. So we'll say we'll only print out the error if there is a problem. Let's say not properly added. But now we're only adding for 1. So does anybody have an idea of how we could possibly improve this tester to test for more edge cases? Well, edge cases are situations where we expect our program to break. So here, we're only testing one case, is when we're adding the first thing to the list. We've never tested when we're adding the second thing to the list. So one way we can do it, it's called unit testing, is we actually create a bunch of these tests. So I'm going to refactor, I'm going to rename this, I'm going to say test add first to ArrayList. You can make a less long name if you want to. I'm making them really long because that's just kind of how I do them. But now I'm going to say test add second to ArrayList. But I could do this. Or I could do test add, let's say, a bunch to ArrayList. And now here's a common debugging strategy that I like to use. I like to use a for loop, and I like to check at every time that we add. So I can say for int I equals 0, let's say I is less than 500, because you only run this once. You don't care about efficiency because it's a tester. So you can do just an absolute ton of them. I is less than 500, I plus plus. And we'll just do this 500 times, and we'll add stuff to our array list. And we're going to add to the front of our array list, so we're assuming that whatever gets added has to be at index 0. But while we're testing it, we also want to test that the size is still correct and everything. So here we can set all of our properties. This is an important part of your tester. This is what we do for your assignments. We want to test all properties. So why don't we create a size method? I don't have a size method yet, but I'll just make one. Public int size. And we'll say return items.length. And now the size has to equal to I believe. Or yeah, the size has to equal I. So if size, or if a.size does not equal I, we'll print an error. So system.println size is wrong. And now we can also check for nulls. So like if for animal A in items, or yes, for animal and in A, But we don't have an iterator, so we can't do that. So I would have to say, I guess, for int I equals 0, I is less than a dot size I plus plus. And we'll say, I guess in J, so silly. I need a tester for my tester. Anyways, we'll say if a dot get J is null, we'll also print out an error. Null element. So does this whole thing kind of make sense to you guys? We're testing a bunch of situations, and we're making sure that in every situation, all of the different properties of our object are correct. And this is a much more robust tester. See, this tester is kind of weak because we're just testing one edge case. Here, we're testing basically every case. We're testing adding something to the start, and we're testing adding a bunch of items until 500, and we're making sure it's all good, right? So now what we can do is we can run both tests. I'll just add my next test to my main method, test, add a bunch to the array list, and let's see if I pass. I might not, because I might have done a typo there. Size is wrong. Okay, so the size should be probably off by 1 here. Let's see. Is it equal to I, or should it be equal to I plus 1? So if I is 0, the size will be 1. So it should be I plus 1. Let's see. That should now give me no errors. How many edge cases should we consider in creating our tester? As many as you can is the answer. Like, there's no way I can say the number because there's many different kinds of edge cases. But I'm going to try to show you guys a lot of the possible ones here. Now, another tester strategy, and the method people mostly screw up, is actually the remove method. And the remove method needs some pretty robust testing. And I'll be showing you guys a lot of test techniques to deal with remove. But before I go into it and everything, can anybody tell me if what I'm doing so far is clear? Or is everything about making testers and debugging making sense to you so far? Okay, cool. So what I'm doing with remove is going to be a little bit more fancy. First, I'm going to make it basic, but I'm going to use the mistakes I run into to help improve my test remove method. So let's call it, for example, public static void test remove. And for the first one, I'm going to make it pretty simple. I'm just going to do a test add. I'm going to add, let's say, 3 items. I'm going to say bad ArrayList BA is equal to new bad ArrayList. We'll say BA.add. And also, do notice the order I'm testing these in. I like to test add first, because if we can't add, we can't remove, right? So making sure add is robust before I try any funny business. I'm going to say BA.add, and let's say, we have to keep track of our dogs. Let's just say animal test subjects is equal to new animal, and then I'll put in the curly brackets which animals I'm going to put in. I'm going to put in, let's say, new dog 2, new cat 4, and new dog 3. I'm just going to put a bunch of these. New dog, set 8. Right, just put in a bunch of these dogs, and now I'm going to just say for animal A in test subjects, I'll add these to the bad array list. So I'll say ba.add A. Now, here I can try to remove stuff. And this is the important part, but I'm just going to say that I'll just do it basically. I'll do it the most simple way possible, and then we'll improve it after. So I'll say ba.remove, and I'll just remove test subjects at index, let's say, 2. And then I'll say if the ba.size is not equal to 3, we'll say it's an error. So system.out.println error wrong size. And now we can just iterate through and make sure the animals are still there. So for animal, or for int I equals 0, I is less than ba.size I plus plus. Now if ba.get I dot equals which one is it? Test subjects 2, and we'll print out that it's still there. Test subject still here. Now we've got our test remove method. Let's run it. Let's see what happens. All right, so right away we get our null pointer exception. Our test subject is still there, and our size is wrong. We're just full of errors. Now, to rehash and reiterate our debugger lesson, like our debugger part, let's do the debugger section first, and let's try to fix this error. And then we'll gradually improve our tester as well. So first off, can anybody tell me what should I do to fix this? What should my first step be to deal with this exception? There's not really a wrong approach to it. Just is there anything I should do? How can I get more information? Put a breakpoint at the line that will enter remove. That's a very good strategy. Now, why do we want to put it at the line that will enter remove rather than inside of the remove method? Like, why do we want to put it before the line that says, or at the line that says remove? Why wouldn't we just put it straight up into the remove method? Okay, well, the reason we don't put it right beside and we put it into the remove method, it's not to be more efficient. It's not for well, any particular reason. It's actually so that we can see what happens before we enter the method. It's very important to understand the context of what's going on when we have these errors. I cannot understate the amount of times that we see people just dying over what's going wrong in their line, because their stack trace says, for example, line 15 is bad, and they're just obsessing over line 15 when line 15 is perfectly fine. What actually matters is what happens before that line. I would say the vast majority of the time, like 90% of the time, the exception and the error, the reason it's happening is the line before the one that's going on, not after. It may be a stupid question, but on top of all the test methods in Minitester, there's an implement runnable class header and the label @override. Is this an important detail in our own tester? No, it's not an important detail in your own tester. Your own tester, if it works, it works. The way that it's structured in our mini tester is designed to be sort of multi-threaded and fancy, and it's all like comp magic. And I'll show you guys a fancy technique at the end that you can use to make like very professional testers, the same kind that are actually used in real companies to test out like actual programs that people are developing. And I'll show you that at the end, not right now. In the meantime, you can just consider all of that stuff in the mini tester to kind of be voodoo magic, and you can either copy it over and use it the same way they do, or not. Runnable is not part of Comp 250, and the @override label just tells your compiler that you're overriding something. Anyways, does it make sense to everybody why we want to put the breakpoint where we put it, rather like why we want to put it in tester rather than to put it into the remove method? Okay, I'll rehash it again. So the reason we put our breakpoint here in the remove method and not inside of our, or here up here rather than the remove method. The reason we put it here is that we don't want to have it cut off any of the lines. Like the exceptions are thrown somewhere inside of remove, but we don't know where. And even if we do know where, we don't know why they're happening. We need the context. So we want to start remove from the very top line. The way we can do this is we can see the context. Here, when I put the breakpoint on ba.remove test subjects 2, I could actually sort of see what's going on around it. I can see what input is going in. So if I put the breakpoint here, I can see the value. What is test subjects 2? Well, I know test subjects 2 is going to be this dog with no friends and an age of 3, right? And I know all of this to be true because I put the breakpoint here. I can see the whole context of how the program is running. That's why I put the breakpoint one level above where my error is coming from. Now I'm going to go into here, I'm going to step into remove, and I'm going to see what's going wrong. How does my method work? Well, my method simply goes through the list, and if the memory address is the same as what we're trying to remove, it's going to remove it. Can anybody tell me what is wrong with this approach? What's like the most glaring thing that was wrong here?
The items I equals a, it should probably be dot equals if it's an object.
That's
not the most.
That is true, and it should be dot equals. We could actually write a tester for it that will make that a problem though. Like we can actually create a tester which will check if we used dot equals or equals equals. And that's actually how we might do it while grading. So before I fix that, why don't I just make a tester for it? I can make 2 identical dogs and we'll put them in the list. And we'll see what happens with equals equals compared to dot equals. Or let's say test subjects 2. Test subjects 2 is a dog, right? What are its properties again? Well, it has the property of age 3 and no friends. So let's create another dog with age 3 and no friends. We'll call it dog fake, or I guess subject to clone. And it's going to be a new dog with an age of 3, just like test subjects 2. And now if we try to remove test subject to clone, and we run this with the debugger, let's see if it'll actually try to remove it ever. Remember, we want it to be able to remove this, because this dog, for all intents and purposes, is identical to test subject 2, so it should be removed. But if I step into here, and I go inside, and I check the equals equals, let's see if any of them are going to be equals. Are we ever going to enter this items I? Not entered, not entered, not entered, not entered, and we're done. So we can see that if I have a clone of the object, and we don't use dot equals, well, that's going to cause an error. And this is how our tester can check if we're using equals equals or dot equals. And that was a good catch there as well. But now that I've added the dot equals, let's see if it runs properly. And again, our thing will still break, but I'm just trying to address this one issue. And using the debugger, I can address this one issue by actually just watching the code run and seeing what it does. Here, it's successfully identified that the dog is indeed dot equals. And I'm just going to check the dot equals method of dog to make sure it's not stupid. Arrays dot equals friends. Does it not compare? Hold on. If dog dot age does not equal this dot get age, turn false. There we go. Now I fixed my dot equals method. The main error was actually not caused by that. That was just an error that was picked up on by one of the students, and I decided to throw that into the tester as well. So let's find the main error, and let's figure out what causes it. Going into the debugger again with remove, we can see that now it's going to successfully use the dot equals method, but we still have the problem of it ending up with something null. Let's see, our new test subjects, or I mean our new bad array list is going to have items, but the item is null. Like the dog we're trying to remove is not there anymore, but it's null. So I see the issue, right? Do you guys see the issue? Instead of removing it from the array list, we just made it null. So now that spot in the array list is null. So although it's removed, it's not a great solution. Does anybody know what kind of a solution might be better?
Yeah, you could always shift down all the elements so you don't have any empty spaces in the middle.
Yeah, we can use a temp array. So let's try that. Let's say animal array temp is equal to new animal, and we're going to make it one less size, right? So temp is equal to new animal, and it's going to be at items dot length -1, so it's going to be one smaller, and we're going to say for temp dot length, and we'll say if animals, or if items I is equal to A, we will do nothing, and else we will say that temp I is equal to items I. Now, this code probably doesn't look too good yet. It's probably still going to break, but let's actually see if it breaks. I'm going to run my tester again. I'm going to see what happens. Error, wrong size, test subject still there. Now, isn't that weird? But we checked if the items I dot equals it. And let's also just get rid of this test subject to clone. Let's just do it back like the way it was before. That was just to show it. Let's just do test subjects 2. All right, so let's see why this is going wrong. If I run with debugger again, using my tester, I can step into here and I can see what's going on. So when I remove, my temp array is created, and I can see in my debugger the value of my temp array. It's a length 3 all null array of animals, and my items array is a length 4 array of animals all full. Now if I go through, I can check if the item is equals A, we're not going to do anything, and if it's I, it's going to copy over. So we copied it over, We didn't copy it over. We copy it over, and we copy it over. But now, we've got a couple of issues. Can we see the issues? We can see that only items 0 and 2 got copied, and one of the fields is still null for our temp array. So clearly something was wrong. And our tester is telling us about that. So that's why the tester is useful. And with the debugger, we were able to tell that clearly our copy doesn't go through all the way. Now let's actually stop inside of our loop, and let's identify exactly what's going wrong. I'm going to put a breakpoint just on this line. And I want to see what happens every time we hit this line. And let's make sure all the copies that we want to happen are happening. We'll get rid of this garbage, and then we'll go into here. Press that one to go to the next breakpoint, and we can see right now I is 0, so it's saying that temp I, and temp I is which one? Temp I is null, and items I is a dog. So this dog is going to be put into temp I. Yep, I saw the mic come on if you have a question.
Oh, that was a mistake, sorry.
Okay, go ahead. Sure. Okay, so we'll go next, and now we're seeing that temp I, which is again probably null, is going to be set equal to items I, which is the cat. And did we successfully skip over the one we wanted to skip over? Yes, we did. We skipped over dog at 827, who we're trying to remove. How do we know we're trying to remove dog at 827? Well, if I go to the method above, test subject 2 is dog at 827, right? So do you see how by stepping above here, we can see here test subject 2 is what we want to remove. And in here, this is indeed gone. But now why is it stopping? Well, I goes up to temp.length. What is temp.length? It's 3. I is currently 2. Let's see what happens next. It's not going to go, right? Because it's going to be less than temp.length. So this is the last I. So it clearly doesn't finish copying. I see. So maybe instead of temp.length, this should be items.length. Maybe this will work. Let's see. If I run the tester now. Ooh, it doesn't work because array is out of bounds. So what happens here? How can I fix this? Well, let's find out why the array was out of bounds. I'm going quite slow here for you guys, I know, but I'm just doing this so we can really see how the debugger works. Well, I know that we could fix this issue with our heads, but the reason I'm showing this on an issue that you guys might be able to instantly debug is that it shows you how you could do this so you can understand the full solution on a problem that you can really well understand. So when you later approach ones you can't understand, you won't be intimidated by the whole debugger part. So here, we're going to go up, and we're going to see what happens when we get to our last index. So our index must be 3. What happens? Well, you can't access temp at index 3. Why? Because accessing an array of length 2, temp is an array of length, a length 3, but we can't access index 3 because it's 0 indexed. So what shall we do? Well, maybe we can use a flag for this. Let's say boolean has removed equals true. But we don't want to declare it here. Let's just say boolean has removed at the top. Boolean has removed equals false. Now it has removed is true. And else if has removed, we will make it I minus 1. And else we'll just make it I. Does this kind of code make sense to everybody, what I changed here? I just said if it's removed it, we'll do it like that. If it's not removed it, we'll do it this way. And now at the end, that should be good to go. Let's try it now. So now our index will be fixed for after we removed our object, and let's hope it still works. Error, wrong size, error, object still here. Okay, it's still broken. Let's try to figure it out once again. So the main error was caused use a temp. What is the breakpoint used for? Sorry, I didn't see that message until now. So could you specify in what context you mean that?
Yeah, sure. It was when you you had remove, and then I think you put another red point on one of the else, I think, just to see what was going on with the out of bounds errors. And instead of having a red dot, you had some kind of circle with like a line over it.
Oh, like this?
Yeah, except it was not red. It was like
that's probably because I just hovered over it. So there's 2 controls I'm using. I'm just using 2 controls. The 2 controls I'm using are to hover and to put a breakpoint. So that's where either of those things came from. If there's a check mark at the breakpoint, that just means we reached the breakpoint already.
Oh, okay. All right. Thanks.
For sure. And the reason we put another breakpoint in here is because sometimes I don't want to click step over 100 times. I just want to get to a certain point, and then I can use the breakpoint and resume. But here, I'm just going to try to see what's going on here? Why am I still getting errors? Let's see. So I'm going to enter my for loop. I'm going to see my 3 cases. So if it has removed it, well, first we'll check which situation is it. So we have not removed, so we're in here and we're setting temp I to items I. Items I, should it be there? Let's hover over items I and see. Come on. It is 829. Are we removing 829? Let's check. Test subjects 2 is 827. Okay, 829, you're safe. You're not getting removed yet. So I go into here. I'll just next line it up. So now what's going on? Items I has removed is false. Now this one will cause an index out of bounds exception. But can somebody tell me, will this exception actually happen or no? Well, this exception won't happen because our I will iterate before it happens, and before it ever has a chance to happen, our if statements will solve it. So our debugger will show us exceptions happening, even if they don't happen. They'll show us if this ever enters, the exception will happen. So now has removed is true. We do I minus 1. We do I minus 1, and we're done. And looks like our temp is actually perfect. So is there something we're forgetting to do here? Oh, I see it. So if we actually hover over temp here, it says, if I exit the debugger even, our temp just says it's useless. It does nothing. Contemps of temps are written to, but never read. That's so silly. We forgot to set items to temp. So let's do that. And now with the help of my tester, hopefully I have a good remove method. And looking at like it, yep, we never got any errors. So do you guys see how this tester was able to help us with removing? Well, it's not done yet. To really make our tester very robust, we should try another case. Let's try removing something which is not in our array. ba.remove new cat, and it's going to be aged that very high age, right? So we know this cat's not here already. Now let's see what happens. We'll say, yeah, if ba.size is not 3, how is items equals to temp? Sorry, I got cut off for a second. I'm just saying that after we modify items, so items is our original array. Temp is the one we create. Here, if we run with the debugger, we can observe that we can observe that our array was properly copied, but we never did anything with it, right? So although we properly copied it, the thing was never updated, and the reason was we never set our field to be our array. So that's why that was the case. And now let's see. I'm going to try to remove if it's equals to, well, yes, if ba get equals to our cat. So this. Yeah, and since we're using dot equals, we can just use the constructor for everything. Let's see if this will work when we remove something that is not in the array. And it looks like when we try to remove something that is not in the array, we get an exception again. Right? And where do we get the exception? We get the exception when we try to remove something that wasn't there in the first place. So this is a huge mark destroyer. If you guys are writing this and you have not tested for removing something that's not in the array, that's a big one. That's a big boy. That's going to get a lot of people. So just make sure you implement this. Where when you remove stuff, this is also an edge case. See, I'm thinking about edge cases. I'm looking at my code and I'm thinking about where will my code break. And this is one of these edge cases that most people don't think of. But it's one of those that you probably need to think of to get a full grade. It's that when you remove, sometimes you might be asked to remove something which you can't remove because it's not there. You see here, I'm copying everything over, but I don't copy over everything because my array is size -1. So I think what I have to do is I have to say items. Let's use that fancy syntax we saw in tutorial 2. We can use that question mark syntax. We can say items equals has removed question mark temp colon items. So instead, this will say that if it's removed something, it will be temp. But if nothing was removed, it'll be items. And now let's see if it works. It might be inverted right now. Yeah, it was inverted, so it should be items temp. Right, now let's try it. Nope, doesn't like it. Why doesn't it like it? Let's see. Again, it's all about the debugger here, all about using our debugger to get through here. And if you guys stick around for the extra few minutes afterwards, I will be showing you guys how to do a much fancier tester that just looks really nice and is very clean and is very professional. But I won't do that right now because let's just get finished with this remove method first. So in my remove method, I'm trying to remove this cat, going through. The cat's not there. Cat never gets removed. Has removed remains false. What's wrong here? What is wrong here? So if we don't want to debug here, we can also just debug by going to the next line. So we'll just step over right here. And why is stepping over not going? Come on. Come on, boy. Shouldn't be so complicated here. Right. So yeah, bad array list here with, what does it have in it right now? Right now it has 4 items. These correct items. Now if we step to the next line, it does have 3 items though. And it goes through and it doesn't remove anything and it should just stop at items.length. And what's wrong with this? Oh, well, it's going to cause an out of bounds exception because when nothing is removed, oh, so I is less than items dot length. But if it hasn't removed by the time it gets to here, it breaks, right? So this is another issue with our code. It's actually in our original for loop that since we go to all the way till items.length and we're here, yeah, it's going to break. So we have to say if I, let's say if I is equals to items.length minus 1. So if it's the last index, we have to do, nothing. So maybe this way it'll work. And now this is a bit patchwork. It's a bit like this method is not clean at all because it was basically written for the tester. But now test subject's still there. What's wrong with that? Maybe my temp items was actually correct in the first place. And now you can see I'm just trying different things and trying to fix it. And I'm using my tester and my debugger to just get my code perfect. And now it's finally working the way it should. So here I had to change a few things. I had to add a few conditions, add a few if statements, and it's not clean whatsoever. But if I go into remove now, we'll see that if we run through it, and I'm going to go through it really fast, has removed remains false with the cat, and then it remains, items remains the same. The size remains the same and everything is set. Are there any questions about the whole tester, debugger, everything idea?
Yeah, I have maybe 2 questions. The first one is for the implementation of the array list. Which one do you think is better, doubling the size every time or just adding 1 to the size like you did in the previous add method?
Well, it's slow to add 1 to the size every time because it will take O of n every time you add something, right? So it's not going to be very fast. However, you also don't have to deal with null. So it's up to you. It's probably going to be easier to write it with +1. And since we're not testing time complexity, you're A-okay to do that. But with doubling, you can have an issue where you'll have a huge amount of nulls in your array. And you have to deal with it because when you do an iteration or when you try to .get from an index that's out of bounds technically, it might give you issues because you have a bunch of nulls, right?
Yeah, but okay, I understand. But in the mini tester, as long as everything's correct with like the sequence, it doesn't matter how big it is, and it doesn't matter if there's a bunch of nulls at the end, right? Like I won't get minus marks if there's a bunch of extra nulls.
I don't know about actually doubling it. My understanding is you should be okay, but I did not write the grader, so I would stay on the safe side, and I would increase the size by 1 every time.
Okay. And the second thing is when I come to remove, should I be I didn't keep resizing the array. I just shifted everything down and left the nulls at the end as well. Should I be resizing it down to the proper size so there's no extra spaces?
That's, again, a more specific question about the grader, and I didn't write it, so I can't tell you for sure. But what I can tell you for sure is if you do resize your array to be smaller, you will not lose points. Now, there's probably a 50-50 chance if we allow the nulls at the end, but in previous assignments, I don't think we did. I think we took off marks for having null at the end. This time, I'm not 100% sure because I didn't write the grader, but I can be relatively sure that that's at least bad form, so it should probably not be the case.
Okay.
In short, to stay safe, I would probably resize the array for a remove method. All right, and the rest of you are welcome to ask questions while I show you the fancy way to do testers. The fancy way requires you to create a special kind of project. when you create your project in IntelliJ, you want to do a new project, like usual. But instead of just doing it the normal way, you got to create it with Gradle. Right? And then you can not check anything off, nothing special. And here I'll call it Super Tester. New window. Now in Super Tester, it's going to have a lot more folders and it's going to be a lot more complicated. And it's going to start off with all this weird stuff. None of that matters too much. This is a very cool way to make testers, and it works very nicely. You will not really easily be able to use them on Eclipse, so sorry Eclipse users, you can do it, but it's just a bit more of a challenge. But these testers will be very cool. So if you right-click on your source folder, I'm just going to copy-paste my code over to the new project. Where is it? A1 review. I'm just going to take... Well, it's not A1 review. We're doing tutorial 4. Right? So I'm going to right-click on this. I'm going to copy-paste my code over, and I'm going to move it to my cool tester. So source, just take all of these, and I'm going to copy-paste them over to my... What's my cool tester called? Super Tester. And then I'm going to move it into... Here, where is it? Super Tester. And we have to wait for it to finish building. It takes a second because it's using a build tool. This is like this fancy program which downloads libraries for you. And it's going to download libraries that make testers a lot more powerful. Now my main folder was generated, so I can go into source, main, Java. It's a lot of folders, but you just put your code into here. And now, if you are on IntelliJ, you should have the option to generate tests. So if I click on cat, I can right-click on any method, generate test. And now when I generate test, it can actually give me my own custom test method. So I can add which methods I want to test on. I can show inherited methods. See, I can test inherited methods. I can test basically every method. Now I press OK, and it creates this special test class. Now this special test class is cool because I have tools like assertions. So I can say, let's say, assert equals assert dot. Yeah, I have to import it, but yeah, or I can say fail. So I need to import assertions. I don't have those, but I can also say fail the test, and I can give it a string. So failed because sound is wrong, and I can say if, make sound, but if, what is the class I'm testing? Dog dot new dog dot make sound is null. We failed because the sound is wrong, right? Or if the sound is not woof, and these tests are just much more clean and much more powerful. So, and these are also what's used in the industry. So if you know how to use JUnit, which is the name of this framework, you will know how to do testers in a way that is what you'll be doing in an actual company. So if it's not equal to wolf, like this, if new, I have to put this exclamation mark before the new. Okay, and now I can run my tests. So I can run the entire tester, and it's going to instantiate tests over here, and it's going to see if I passed or failed my tests. And here I failed my test, and it tells me why. And then these tests are actually built into your IDE. And here I can run each individual test, and I can run only the tests that failed or only the tests that pass. So here I can rerun only the tests that were wrong, rerun failed tests. I can run all of the tests. And this framework, the tests are the same. I repeat, the tests are exactly the same. You write the same tests with the bonus version, the JUnit version, or the normal version. But the JUnit version makes your organization more clear because you can just run an individual test. Like, if you remember in Python or whatnot, you can just run individual snippets of code. It's like that. You can just run the method. See, I've got no main method here. I just run the tests. And that can be really helpful because if you're just trying to debug one thing, you don't want to waste time running 100 other tests. You can just run the tests you need. And you can also generate tests. So if you right-click on any method, you can generate a test. And then you can do all of these different setup things, which are, again, above the scope of Comp 250, completely optional. But you can generate this test. And then you can just select which methods you want tests for. I want tests for everything, right? And done. You can create testers like that. And you can run each individual test individually. If I go into my tester file, I can copy-paste my code. So where's my test remove? Here's my test remove. To convert it to a JUnit test, I find my tests in the test folder. I paste it into remove here. And instead of system out println, I can say fail. Fail. And now that is a different way to run a tester. And if I run this tester after I change all of these to fails, I will have one that is very professional, very nice looking, and you can easily share these. This is the format that people used when they were on bestofcomp.com, like for the fanciest testers of last semester. And yeah, again, to do this, you go File, New, Project, and you select Gradle from the project types. Are there any questions now at the end of the session? Or yeah, if there are, I'm happy to answer. Otherwise, should be good to go. Good luck debugging on your assignments. YouTube videos are available on how you can share and collaborate testers with your students or fellow students. Those are already released, and I can link them as well. Alrighty, I'll just leave a little bit of time for any further student questions, and if there are none, I'll wrap up shortly. All right. If any of you are watching the recording or have questions, anything like that, Piazza office hours are available, or of course you can always come to the next session and see the thing in person, ask the questions at the end of the session. All right, thank you guys, and I will see you guys later.